Alright, today we are going to add and subtract polynomials, which pretty much is just identifying like terms and adding them together. So hopefully it's not a huge stretch of a new concept. So the first thing, we're just going to add or subtract. Add or subtract. With these first ones, there's nothing extra you're going to do. You're just going to add or subtract. So the first one we have is 15m cubed plus 6m squared plus 2m cubed. The first thing we want to do is we want to identify like terms. Now remember, like terms are where you have the same variable and the same exponent attached to that variable. The whole number or the constant in front doesn't matter if it's different. So we're going to rewrite these so our like terms are together. So that would be the second thing. Rearrange. So 15m cubed and 2m cubed both have an m with an exponent of 3. And then 6m squared, it has a variable of m, but the exponent's 2, so it's not a like term. So what we can do then is we can add our two terms that have the same exponent and same variable, and when we add them, the only thing we add are the whole numbers. So we have 17m cubed plus 6m squared. So combine like terms would be the third step. And then you can look at that, and from our lesson the other day, you can tell that's a third degree binomial. So the next one, we have 3x squared plus 5 minus 7x squared plus 12. So we're going to rearrange these so our like terms are together. We have an x here and an x here, and both of those x variables have an exponent of 2, so those are like terms. So we 3x squared, and the 7 has a negative sign in front of it, so we're going to bring the negative sign over. And then if we look at the 5 and the 12, neither one of those have a variable, so they are like terms simply because they're just whole numbers. Plus 5 plus 12. Now we can combine our like terms, and we have 3 minus 7, which is negative 4, and our variable stays and our exponent stays, and then we add our two whole numbers of 5 and 12 and get plus 17. I'm going to do the next one right beside it. 0.9y to the fifth minus 0.4y to the fifth plus 0.5y to the fifth plus y to the fifth. Actually, that last term, I just looked closer, it looked like it was a y, but it's an x. So let's change that. That should be x plus y to the fifth. So, looking at that, we have a y, and a y, and each one of those y's has an exponent of 5. So we're going to write those so they are all together. Now if you can identify your like terms before you write the problem out, you can just write the problem out in order, or with the like terms together. So you could just start with writing that out if you want. And then we combine our whole numbers. So 0.9 minus 0.4 is 0.5, or 1/2, and 1/2 plus y, which has a 1 in front of it. If you can't see it, it's a 1. So we get 1.5y, and our exponent stays the same at 5. And then we have nothing to combine with the 0.5x to the fifth because there's no more x's. So we just bring that straight down and tack it on to the end. Sometimes you'll get these problems where it'll be like 2x squared y minus x squared y minus x squared y. That's not the type of problem I thought it was. Each one of those have an x with an exponent of 2 and a y with an exponent of 1. So you can combine those, and it's 2 minus 1, which is 1, minus 1, which is 0. And if your answer equals 0, you don't need to attach the exponent, or the variables and exponents to it. What I was thinking this problem was like this one. I'm going to make one up. 5m plus 3n squared plus 5y. Now if you get a problem like that, you have no like terms in that problem. So if they give you a problem like that and there are no like terms, that is your answer. You don't have to do anything with it, which is kind of nice. So now we're going to add polynomials. What we just did was adding and subtracting monomials. They were 3 separate terms or 4 separate terms, and they didn't have anything like parentheses. So if you are given a problem with parentheses, that's where they're going to tell you that you're adding polynomials, because you're not just adding one term with the next. You are having to do some extra work. That is not erasing. I don't know what happened. So, adding polynomials. So, our first problem is 2x squared minus x plus x squared plus 3x minus 1. And there are 2 different ways you can do this, and I'm going to show you those 2 different ways. I'm going to do a few the first way and a few the second way, and actually this is in parentheses as well. Okay, because this is a plus sign right there, we can just eliminate the parentheses. So we can have 2x squared minus x plus x squared plus 3x minus 1. And now we look like we're just adding monomials like before, where we go through and we're like, all right, 2x squared plus x squared, those are like terms. And when you have a long string of them, I like to cross them out after I write them down, so I don't write them down twice. Minus x plus 3x, those are like terms, so I'm going to cross those ones out. And then I'm going to put minus 1 at the end, and then I'm just going to go through and I'm going to combine. And I have 2x squared plus x squared, which is 3x squared, negative 1 plus 3, which is 2, and then I'm going to bring my negative 1 down because I don't have anything to combine it with. And that's my answer. The next problem we have is negative 2ab plus b plus 2ab plus a. Okay, again, I have a plus sign, so I can just eliminate the parentheses. Because when you multiply by a positive 1, if you were to do distributive property, they would just all be the same. Now I'm going to identify my like terms. I got negative 2ab plus 2ab, so I've used these 2, and then I have plus b plus a. Well, negative 2 plus 2 is 0, so I can go ahead and just cancel those out, because if it's 0, I don't need 0ab, and then my answer is just simply b plus a, because I can't combine those because they're not the same variable. Alright, so there's a second way to do this. Which is not my favorite. I like doing it the first way, but I'll show you this way in case you like this way better. I don't really know of kids who do, but you know, one of you might surprise me. The 5th plus 6b minus 7b to the 5th plus b. So the second way of how we do this is we simply just add. So I'm going to put 4b to the 5th plus 8b, and I'm going to put my like terms underneath it. So I have a positive 3b to the 5th, and I have a negative 7b to the 5th. So I've used these up, and then I've already used my 8b, so I have a plus 6b, and then I have this little positive, is that a 6 or, oh, that's a b too, it looked like a 6 to me. I have another plus b. I should probably write that over to the side. Okay, so I've used everything. And then I just add vertically. 4 plus 3 is 7, minus 7 is 0. So these ones don't matter. 8 plus 6 is 14, plus 1 is 15, and I have 15b as an answer. So let's try another one like that. 20.2y squared plus 6y plus 5 plus 1.7y squared minus 8. So now my like terms, setting your problem up vertically is identifying your like terms. It's just a different way of identifying them rather than going horizontal. Then you have plus 6y. There's no 6y in the second, or no y in the second polynomial. And then you have plus 5 minus 8. So these cancel. So you have 20.2 minus 1.7, or plus 1.7, sorry, which is 21.9y squared plus 6y, because there's nothing underneath it to add to it, minus 3. And that's your answer. Maybe I don't mind doing it that way. I don't know. So the next thing, so that was adding polynomials. Now we are going to subtract polynomials. Subtracting polynomials sometimes confuses people because there's an extra step and they forget to do that extra step, and then they can't figure out why they got the wrong answer. But if you remember the extra step, they're just the same as adding. So we have 2x squared plus 6 minus 4x squared. Now if you notice, before we had a plus sign between the two polynomials, and if you have a plus sign, you can just drop the parentheses. If you have a negative sign, you cannot drop the parentheses for the set of parentheses that follows the negative sign. So here we have a positive sign technically because there's no sign, so you can just drop the parentheses. But the term that follows the negative sign, everything inside those parentheses needs to be changed to its opposite. So right now you have 4x squared, which is positive. Because of that negative, that's like saying negative 1 times 4x squared, which gives me negative 4x squared. So anytime if you have a negative distribute. Okay, so then now we're down to just back to our normal thing of, okay, 2x squared and minus 4x squared, those are like terms, and then plus 6. And then you combine 2 minus 4 is negative 2. x squared, and since you don't have anything to add your 6 with, you just put that at the end. So here's another one. A to the 4th minus 2a minus 3a to the 4th minus 3a plus 1. So this first set has a positive sign in front of it, so we can just drop the parentheses. The second set has a negative in front of it, so we need to change each one to its opposite. So positive 3a to the 4th becomes negative 3a to the 4th. Negative 3a becomes positive 3a because negative 1 times negative 3 is positive, and positive 1 becomes negative 1. And then we get our like terms together. A to the 4th minus 3a to the 4th, be a little 4, those I'm done with, minus 2a plus 3a, those I'm done with, minus 1. So this is like having a 1 in front of it, so 1 minus 3 is negative 2a to the 4th, negative 2 plus 3 is positive 1, so I can have plus 1a or just plus a, doesn't matter, and then bring the negative 1 straight down. And then of course you can do these the vertical way as well. Oops, like we did right here, if you want to. You don't have to though. You do whatever is best for you. But with the vertical way, with the subtracting, sometimes you forget to change out the negatives. At least I do, so I don't do it that way. So it says the profits of two different manufacturing plants can be modeled as shown, where x is the number of units produced at each plant. Write a polynomial that represents the difference, there's our math word, of the profits at the eastern plant and the profits at the southern plant. So, because eastern came first and southern came second, our eastern polynomial is going to go first and our southern polynomial is going to go second. And because it says difference, we're going to subtract the two. So we have negative 0.03x squared plus 25x minus 1500 minus negative 0.02x squared plus 21x minus 1700. Now, the first set has a positive sign in front of it, so we can just remove the parentheses and not do anything special to the terms inside. Whereas the second set has a negative sign, so if we're going to remove the parentheses, everything needs to be changed to its opposite because we're multiplying each term inside by negative 1. So plus 0.02x squared minus 21x plus 1700. Then we rewrite our like terms. So we have negative 0.03x squared plus 0.02x squared, so we can get rid of those, plus 25x minus 21x minus 1500 plus 1700. And yes, I am making sound effects, which gives us, when we combine, negative 0.01x squared minus 4x plus 200 for an answer, and we are done.